Hello students, warm welcome back to all of you. In the previous module we discussed about tangential properties of circles. So in this module we are going to discuss few more properties of tangents of a circle, and of course we discuss few set of problems which were given in previous board examinations of our CBSE curriculum. So whatever all we discussed previously, let's have a quick look on this. So what do you mean by a tangent? A tangent is a line which touches the circle in only one point. For the given circle, we can draw infinitely many number of tangents. And after that, a tangent is always perpendicular to the point of, is perpendicular to the radius through the point of contact. And after that, we discussed how many number of tangents that can be drawn to a circle from an external point. And of course, we discussed and we derived all these things in our previous module. So now we are going to discuss few set of problems on that. So the next one is, suppose if you have a tangent drawn from an external point of a circle, and you know that the tangent is always perpendicular to the radius through the point of contact. So basing on this particular concept, we are going to discuss few more things now. So the number of tangents that can be drawn passing through a circle is infinitely many, but if you have a single point external to it, then how many number of tangents that can be drawn to a circle? Then there are two tangents drawn to a circle passing through any 2 points on a circle from an external point of the circle. And after that, radius is perpendicular to the tangent through the point of contact. Suppose if a quadrilateral is circumscribing a circle, then what is the relation between the sides of the quadrilateral? That is what we are going to discuss. See here, I have a circle. So this is one circle, and this is one tangent, and this is one more tangent. If you would observe, this is one more tangent, and drawing one more tangent to the circle. See, you can call this quadrilateral is a circumscribing quadrilateral over circle, right? So the quadrilateral circumscribing a circle, and the vertices of the quadrilateral are A, B, C, D. Then what is the relation between the sides? So the relation between the sides is AB plus CD is equal to BC plus AD. It means sum of opposite sides are equal. That is what we are going to discuss now. Did you understand what are we going to discuss? If a quadrilateral is circumscribing a circle, what do you mean by circumscribing a circle? The quadrilateral is drawn through 4 points on the circle. It means the circle should be inscribed, right? Then the relation between AB, CD, AD, BC is AB plus CD is equal to AD plus BC. That is what we are going to discuss, right? So that is what the statement, and we are going to discuss what is the given information. So given information is A, B, C, D is a quadrilateral. ABCD is a quadrilateral circumscribing a circle, right? Circumscribing a circle. And what are you going to prove here? You are going to prove that sum of opposite sides equal. It means AB plus CD is equal to AD plus BC. So for that, I am going to consider the points of contacts of tangent to the circle. So what are the points of contacts of tangent? So this is one point of contact, let it be P, and this is another point of contact, let it be Q. This is another point of contact, this is R, and this is another point is S. But we already discussed one of the previous concepts, that is how many number of tangents that can be drawn passing through a circle, and how many number of tangents that can be drawn to a circle from an external point. If you would observe, how many number of external points are there for this circle? See, here A is one external point, B is one external point, C is one external point, D is one more external point. So as per that theorem, lengths of tangents drawn from an external point of a circle are equal. So, what do you mean by that? AP is equal to AS. So, this part is equal to this part. Similarly, DS is equal to DR. So, these two parts are equal, and CR is equal to CQ. So, this part is equal to this part, and BP is equal to BQ. So, this part is equal to this part, right. So, by using that particular theorem, I am going to prove AB plus CD is equal to AD plus BC. For that, what am I going to prove here? I am going to prove that taking left hand side. So, here left hand side is AB plus CD, right, but AB is divided into AP as well as PB. So, that instead of AB plus CD, I am going to write AP plus PB, and instead of CD, I am going to write CR plus RD, because R is a point on CD dividing into two parts. They are CR and RD. So, instead of CD, I am writing CR plus RD. So, CR plus RD, right, which is equal to AP. What is AP? AP is exactly equal to AS, right? Okay. So, instead of AP, I am going to write AS, and instead of PB, can I write BQ, because PB is equal to BQ. So, AS plus, instead of PB, I am writing BQ plus, what is CR here? CR is equal to CQ, plus RD is exactly equal to SD or DS. SD. Now, you once observe, this is AS and this is SD. I am writing them together. So, when I write them together, then AS plus SD plus, this is BQ and this is CQ. So, BQ plus CQ. Once observe, what is this AS plus SD? AS plus SD is equal to AD, right. So, which is equal to AD plus, what is BQ plus CQ? BQ plus CQ is going to be BC, which is equal to BC. So, finally, what we got? We got AD plus BC. So, by taking AB plus CD, we proved it as AD plus BC. So, hence proved. What did you observe from this theorem, and what did you learn from this theorem? If any quadrilateral, I would say any quadrilateral, that quadrilateral can be a parallelogram, a rectangle, a rhombus, or a square, or a kite, whatever it is, right. So, if any quadrilateral is circumscribing a circle, then we can say that AB plus CD is equal to AD plus BC. Sum of opposite sides are equal, and this is the way to prove that statement. Hope you understand, right. So, moving on to the next statement. So, the next statement is going to be, here we already proved that lengths of tangents drawn from an external point of a circle are equal, and the second thing is radius is perpendicular to the tangent through the point of contact, and the third one, just now we proved that if a quadrilateral is circumscribing a circle, then it is then sum of opposite sides are equal. Now, I am taking one specific quadrilateral. So, what is that specific quadrilateral here? That specific quadrilateral is a rhombus, and it is basically a parallelogram that I am taking. See, what are the properties of parallelogram? If you observe the properties of parallelogram, in a parallelogram, opposite sides are parallel as well as equal, right. So, here A, B, C, D is a parallelogram. Then what? So, if it is a parallelogram and a parallelogram is circumscribing a circle, then we can prove this parallelogram ABCD is rhombus. We can prove that parallelogram ABCD is a rhombus. That is what I am going to write the statement. So, the statement is going to be, if a parallelogram circumscribing a circle, if a parallelogram circumscribing a circle, then we can prove that it is a rhombus. So, then it is a rhombus, right. So, how do you prove that it is a rhombus? For that, you need to understand when a parallelogram is said to be a rhombus, and what are the properties of parallelogram to be a rhombus, right. So, basically, what are the properties of parallelogram? In parallelogram, opposite sides are equal, opposite angles are equal, opposite sides are parallel, diagonals bisect each other. So, out of all these properties, which is the property is useful in order to prove our parallelogram circumscribing a circle is a rhombus, and when a parallelogram is said to be a rhombus? See, I just draw one parallelogram. So, this is one parallelogram, right. So, in this parallelogram, opposite sides are equal and of course parallel, you know already about this, right. See, suppose if you can make one pair of adjacent sides are equal, for example, the length of this side is equal to some 5 centimeters, length of this side is equal to some 3 centimeters, right. Suppose if I can make this 5 centimeters into 3 centimeters just by reducing the length of the side, then for example till here, from here to here it is 3 centimeters. So, if this is 3 centimeters, obviously you will have to make this one also 3 centimeters, right. And then when you join both these 2 points, obviously there is a quadrilateral formed. So, in this particular quadrilateral, this is 3 centimeters, you made this one also 3 centimeters, it was already 3 centimeters, so this is 3 centimeters. It means all the 4 sides are equal just by making one pair of adjacent sides are equal. So, what do you mean by that? When a parallelogram is said to be a rhombus, if you can make one pair of adjacent sides are equal, then that parallelogram is said to be a rhombus. So, what does it mean? If you can make AB is equal to AD, then it is a then the parallelogram is a rhombus. Otherwise, if AB is equal to BC, then also it is a rhombus. If BC is equal to CD, then also it is a rhombus. It means if you can prove that one pair of adjacent sides are equal in a parallelogram, then it is said to be a rhombus, as simple as that. So, that I am going to utilize that information in order to prove our statement. So, if a parallelogram is circumscribing a circle, then it is a rhombus. So, I am exactly using the same information in order to prove this parallelogram is a rhombus. So, what it is and what are given? So, given that ABCD is a parallelogram. So, in a parallelogram opposite sides are equal, I am going to write that. So, that means opposite sides are AB and CD both are equal, as well as AD is equal to BC both are equal, right. So, what am I going to prove here? I am going to prove that ABCD is a rhombus. So, in order to prove that a parallelogram is a rhombus, as we discussed earlier, you need to prove one pair of adjacent sides are equal. So, that is, it is enough to prove that, one pair of adjacent sides are equal. One pair of adjacent sides are equal in a parallelogram. So, one pair of adjacent sides are equal in a parallelogram means you will have to prove either AB is equal to AD or AB equal to BC or any one of the pair of adjacent sides are equal. So, for that I am utilizing the information or theorem or the statement we just proved. What was that statement we just proved? See, ABCD is basically a quadrilateral. If a quadrilateral is circumscribing a circle, then we can say that AB plus CD is equal to AD plus BC, right. Just now we proved that. I am going to utilize this information. So, we know that AB plus CD is equal to AD plus BC, right. So, AB plus CD is equal to AD plus BC, since the quadrilateral is circumscribing a circle. Once you observe what is the information given here, AB is equal to CD. It means in the place of CD, you can write AB, okay. So, that implies AB is AB and CD is also is equal to AB, which is equal to AD is AD plus what is BC, instead of BC I can write AD as it is a parallelogram. So that I would write AD again. See, after writing that, AB plus AB is equal to 2AB, which is equal to AD plus AD is equal to 2AD, right? When 2AB is equal to 2AD, can we say that AB is equal to AD, right? So what do you mean by this AB is equal to AD? AB is equal to AD. It means one pair of adjacent sides are equal in parallelogram. If one pair of adjacent sides are equal in parallelogram, what do you call that? It is a rhombus. Therefore, ABCD is a rhombus, right? So this way we can easily figure out this statement, and of course these are all the problems given in previous board examinations. When a parallelogram is circumscribing a circle, it's a rhombus, and in fact according to the weightage, board weightage of CBSE curriculum and CBSE examinations, this concept called circles carries almost about 7 to 8 marks. So please do remember, and in which areas you will have to be focused more on, and especially finding the tangential properties of circles. And see, altogether we have 16 problems in an exercise, and out of 16 problems, if you would observe clearly, all these 16 problems all the time, if you see the previous board examinations, definitely 1 or 2 problems will come exclusively from the textual exercise problems. So that you will have to be focused more on these problems to score better marks in your 10th class board examinations. Hope you understand and enjoy the class. Thank you.